Hey, here we have the antiderivative of the cosecant of theta over the cosecant of theta minus the sine of theta d theta. And, we have a quotient here, so basically this is just trig. We're going to rewrite this. We're going to do a little bit of trigonometric manipulation in here so that we can integrate this, because, I mean, how do you integrate it right now? You have no rules for quotients, period. You have to rewrite them, or you have to use some kind of, probably you're going to learn a bunch of forms of taking antiderivatives of quotients in Cal 2. I don't know how your calculus course is set up, but the one that this is actually designed for is set up that way. So anyway, what you're going to have to do is you're going to have to rewrite this expression so in order so you can get it into something that you can integrate. And what I suggest you do, I guess you could multiply by the conjugate of the denominator, although I'm going to go a different route. I'm going to say just like in trig, when we have things other than sines and cosines, let's go completely into sines and cosines. So the cosecant of theta is 1 over the sine of theta. And you know what? I'm gonna change this up a little bit because I think it's gonna come out neater this way. I'm gonna bring that cosecant out in front, and I'm gonna say it's a product, so it's multiplied by 1 over the sine of theta, and then that's gonna be times 1 over. I think this is much easier to do actually, and I'm not gonna change this. Well, why not? I said I would, so I am going to. Probably could have just gone right there, and you know that sine times the cosecant is just 1. But anyway, I said I was going to change it to sine, so I am. So it's 1 over the sine of theta, which is the cosecant of theta, minus the sine of theta, d theta. Now I'm going to multiply through by that 1 over the sine of theta, and we get 1 times 1 in the numerator. Sine times 1 over the sine is 1. Sine times negative sine of theta is minus sine squared of theta, d theta. And now you say, well, what do we do? Well, what about thinking about the Pythagorean identities again? And we have the cosine squared of theta plus the sine squared of theta equals 1. So solving for the cosine squared of theta, I get 1 minus the sine squared of theta, and look, that's what I have in that denominator. So I actually have here 1 over the cosine squared of theta, d theta. And what is 1 over the cosine squared? Well, that's also known as the secant squared of theta. So we need the function whose derivative is the secant squared of theta. Well, if you know your derivatives, that's the tangent of theta plus c. So that's it. I like these. I like trig and I like integration, so this was actually kind of fun. That's it. Thanks. You could, I don't know if you'd really want to derive and then try to go back to this point. But this is what all those proofs you did were back in trigonometry, if you took it, were for. And it's what you should go and do some proofs for if you haven't.